Okay, let's have a look here. So we start off case 1. We want to prove it's true for n equals 1. So that means 1 over 1 plus r is less than or equal to 1 over 1 plus r. N is just 1, that's obviously true. 2, assume it's true for n equals k. So that's 1 over 1 plus r power k. Right. K's in the denominator, but I'll keep it in the same form. Less than or equal to 1 over 1 plus kr. 3, required to prove case n equals k plus 1. So that's 1 over 1 plus r power k plus 1 is less than or equal to 1 over 1 plus k plus 1 r. So usually for these inequalities we start from 2, and we have 1 over 1 plus r power k is less than or equal to 1 over 1 plus kr, and we multiply both sides by 1 over 1 plus r. So what will happen is on the left we'll get 1 over 1 plus r power k plus 1 is less than or equal to 1 over 1 plus r plus kr plus kr squared. And basically we've shown that this is less than this. So if we can show that this second piece here is less than this piece, less than this piece, we're done. Because remember, we're trying to show that this piece on the left is less than this piece on the right. So far we've shown that the left piece is less than this guy. So all that's left to do is to show that this guy is less than this guy. This is the standard inequality technique for the proof by induction. So required to prove 1 over 1 plus r, required to prove 1 over 1 plus r plus kr plus kr squared is less than or equal to 1 over 1 plus k plus 1 r. So that means we need to prove that 1 over 1 plus r plus kr squared is less than or equal to 1 over 1 plus kr plus r. Now what's interesting here is the numerators are the same, and 1, 2, 3 are the same in the denominator. So that means this will be true as long as that piece there is positive, because it'll make the denominator bigger, it'll make it a smaller fraction. So this is true as long as kr squared is positive, and r squared is positive because it's r squared, and k is positive because k is 1, 2, 3. So that's actually done for step 3. So step 4, 1 plus 2 plus 3, that implies it's true for n equals 1, 2, 3, etc. So that ends the proof here. Now for the second part, so since x is between 0 and 1 and r is positive, that means it's possible to let x equals 1 over 1 plus r, i.e. as r approaches 0, that would mean x approaches 1, and also as r approaches infinity, that would mean x would approach 0. 1 over infinity. So it's possible that if x is between 0 and 1, or is positive, you can make x equal to 1 over 1 plus r. So you can choose an or so that this equation is true for any x between 0 and 1. So that is choose or such that x equals 1 over 1 plus r. That's the idea here. So then that would mean x power n would equal 1 over 1 plus r power n, which will equal 1 over 1 plus r power n, which would be less than or equal to 1 over 1 plus n(r). So then the limit as n goes to infinity of x power n will be less than or equal to the limit as n goes to infinity of 1 over 1 plus n(r). As n goes to infinity, this becomes 0. But the limit here has to be positive, since, well, actually, yeah, since x is positive. So what that means, if the limit has to be greater than or equal to 0 and less than or equal to 0, then that means it's getting squeezed and the limit is going to be equal to 0 then. Okay.